work through another example of a structure passing into functions by reference and also by value, and then use this new structure in subsequent recordings for arrays of structures and linked lists and all kinds of interesting things. So the structure I want to work on right now is that of a point. Suppose you wanted to store the x and the y coordinate of a point in the plane, for example, in a structure. So we declare a structure and call it point. And what it needs is an x coordinate and a y coordinate. Let's say those are integers, int x, int y, and there's my structure. Next, we want to declare an instance of the structure. So struct point needs to be written here again, struct point, and let's call it z. So z is my point. And let's say, again, we want to write two functions as we did before. One where the user enters the coordinates of a point, so let's call that read point. And in order for the user to be able to modify what's stored in z, we need to pass the address of z to this function. And so let's write that function. So it has no return value, so void is the return type. Read point is the name of the function, and we pass to it a structure pointer. So a pointer to a structure by the name of struct point. Maybe we enter a message for the user here, enter a new point. Start a new line there as well. And so they need to enter an x coordinate. And then comes our scanf function. So we're reading an integer, so a %d, and where are we putting that integer? Remember, ptr is a pointer to our structure, so we need to first dereference that in order to get to the memory location that the structure is stored. And then we need to go to the element of the point that stores the x coordinate, and we call that x. And to do all those things in one step, we learned we can use this arrow. So that dereferences the pointer and then goes to the member x of the structure. So that is the memory location where we want to put the value that we're reading. And in order for scanf to be able to access that location, we need to put the ampersand in front of it and pass that to the scanf function. We can put parentheses around here just for clarity, but we don't have to because the arrow here has a higher level of precedence than the ampersand set. So that's all we need to do. And then we do the same thing with a y coordinate. So we want the user to enter a y coordinate. And then we scanf and p again because the y coordinate is also an integer. And this time we go ptr, dereference, and go to the member y. And then we need the address of that member so that the scanf function can write into it. And we should be spelling scanf correctly. Here we go. And that's all that this function read point needs to do. In order to verify that everything went well, we also need a function print point. So this time, we only need to pass the point itself to the print function because we don't want to modify it within the function print point. So let's write our function print point. Again, the function doesn't return anything, so the return type is void. Point. We're passing to it a structure point and not a pointer, and so we call it pt right here. And what we need to do is we need to print out the x and the y coordinate. And so how about we put that in like some kind of coordinate notation? So parentheses open, %d, comma, %d, close parentheses, and then maybe even a new line. And what is it that we're printing out? We want the x coordinate of pt. This time pt is not a pointer, so we use just the period to get to the member x of pt because pt itself is the structure that stores the point. So pt point x and pt point y is what address the x and the y coordinate of the point we wish to print. So again, the difference between using the arrow and using the point is that when using the arrow, that means we have a pointer to a structure that we need to dereference first and then go to the x member. Whereas down here, pt.x, pt is the structure itself, and we want the x coordinate of that structure. All that's left to do is write our prototypes. So let's copy those quickly up here. For read point, we also need a prototype. They both need to go underneath the structure definition because we need to know what the structure is by the time the compiler gets to this line. And that should be it. So let's compile and run this step by step. First, we declare a point z of type structure point. There it is. And you can see in memory, space is reserved for the x coordinate z.x and for the y coordinate z.y. Next, we pass the address of z to the read point function. And so the read point function received an address. The address here is FFF8, and if you look at the memory visualization, FFF8 is exactly where z.x starts. So the read point function knows where the point is stored in memory, and that information is stored in PTR. So next we're printing out enter a new point, and an x coordinate, and then there's the scanf that's waiting for the x coordinate. So I need to type in something, how about 3 for the x coordinate, and watch what happens. The 3 showed up in z.x, despite the fact that a read point only has the address PTR. PTR was dereferenced, so it went to FF8. It knows the structure z starts there, and it was able to go to the x coordinate. Next, we're printing out enter a y coordinate, and again I need to enter something, how about 4 for the y coordinate, and the y coordinate shows up in z.y. Again, we only know what the address of z itself was, but by dereferencing that address, the computer is then able to find the y member. Next, we want to print the point z. So we pass the point z, the whole structure, to the print point function. And watch what happens. This time, a copy was made. So the contents of z was copied into pt. The print point function has its own variable, pt, of type struct point. And the values z.x and z.y, 3 and 4, were copied into pt.x and pt.y. So the print point function works with this copy, and that's why if you modify pt.x or pt.y within the print point function, that's nice, you can do so, but it won't affect z itself, which is using the main function. That's what we need to pass an address of z to the read point function if we wanted to modify something. Okay, so let's go one step further. We're printing out 3, 4, the coordinates, and the program terminates. So this is a nice brief example that's easy to look at in memory, and because we're going to do a lot of visualization in the next few examples, this is the example that we're going to continue working on.